This is Vishal. Vishal is a student in need. He doesn't know anything about physics. And with your donation of $5 a day, you can help Vishal and many other students in High School North gain a knowledge that they never had before. So hopeless, so miserable. Please, be kind in your donations. People like him can find a better life. With your donation of $5, you'll get a complimentary physics video. The video that you'll be getting is about torque, gravitation, and many more topics. Please do be generous with your donations. Please, help the children. Help the children! Oh great, look, you donated. That's awesome. Let's cut to the video now.
Hey, welcome class, Vishal.
He has a question.
Yes? Is John Bartel in this class? No, I'm sorry, he's not in this class. Aww. Today we're going to learn about centrifugal force, torque, and mass. So first we're going to talk about centrifugal force. Centrifugal force is a force that makes a body follow a curved path, and its direction is always orthogonal to the velocity of the body, toward the fixed point of the instantaneous center of curvature of the path. The object is also attracted to the middle. The equation for centrifugal force is force equals mass times velocity squared divided by r. The net force towards the center of an object must always equal the centrifugal force. Centrifugal acceleration is due to when an object has constant circular motion. In order for an object to execute circular motion, even at a constant speed, the object must be accelerating towards the center of rotation. Alright, next we're going to learn about torque. Torque is spelled T-O-R-Q-U-E. Torque. Torque is a measure of how much a force acting on an object causes that object to rotate. The equation for torque is torque equals R, which is the length of the lever arm, and that's multiplied by the force. Object is balanced, then there's no net torque on that object. The angular acceleration of an object is equal to the net torque on the object divided by the moment of inertia. Vishal, what is rotational speed? What is rotational speed, Vishal? Alright, now we're going to move on to center of mass. Center of mass is when an object is balanced on its pivotal point. At an object's center of mass, it moves as a point particle would move. I'm going to show you an example of center of mass. So if I was to hold this eraser on one finger, the center of mass would be in the middle of the eraser. So like there, approximately. For an object to be in static equilibrium, it needs to be in transitional equilibrium, which means the net force on the object is 0, and net torque on the object is also 0. Bishop, can you please
Sir.
demonstrate? Didn't even finish the question.
Alrighty.
Okay, so we're going to move on. Alright, next we're going to talk about Newton's universal law of gravitation. So this law is the force of attraction between two objects must be proportional to the object's masses, or gravitational force. Newton believed that the same force of attraction should exist between two objects anywhere in the whole universe. Universal law of gravitation proposes that the objects attract other objects with a force that is proportional to the product of their masses and inversely proportional to the square of the distance between them. The equation for this is force equals gravity times m1, the mass of the first object, times m2, the mass of the second object, times r squared. In this equation, g stands for the gravitational universal constant, m1 stands for the mass of the first object, m2 the mass of the second object, and r stands for the distance between the two objects, and this variable is squared. Now we're going to talk about weight and weightlessness in relation to gravity. Weightlessness is caused by the shuttle being pulled down by Earth in orbit. And if you're on this shuttle, you have no apparent weight, and everything inside the shuttle will be floating. Any object with mass is surrounded by a gravitational field, in which another object experiences a force due to the interaction between its mass and the gravitational field. The equation for weight equals force, which is the weight pulling you down, and that equals your mass times gravity. On Earth's strength of the gravitational field is 9.8. Mass, as used in the law of universal gravitation, determines the size of gravitational force between two objects. So Vishal, can you explain what gravitational force is? Vishal, can you please come up to the board and match these laws with their definitions? Good job, Vishal. How did you know these were the right answers? Vishal, what does that have to do with what we're learning in class today?
Well, I can feel the centripetal force as it's acting.
Vishal, what do you got there?
I think it's a moment.
And what does that have to do with what we're learning about in class?
Well, I had to balance out the torques and find the center of mass to make this.
Good job.
This is actually my nail polish.
Alright, one last problem, Vishal. Can you solve this torque equation where the R equals 2 and the force equals 2? What does torque equal? Good job, Vishal. That's correct.
Soldier Boy Dre. Oh, we made it. Turn me up just a little bit in the headphone. Worldwide, international.